Antarctica is often seen as a frozen margin of the world, a place defined by ice, distance, and silence, rather than by history. To most people, it appears empty and unchanging, a continent where nothing unexpected could exist. That impression persists because Antarctica reveals almost nothing at first glance. In reality, Antarctica is not a surface. It is a buried continent. In many regions, 1 to 4 kilometers of ice, pressed down on terrain that has never been directly observed. Beneath the ice lie mountain ranges, deep valleys, ancient river systems, and vast bodies of liquid water. These features are known to exist only through radar and seismic data. Much of the continent is confirmed on paper, but remains unseen in reality. These limits have shaped how Antarctica is explored. Even with satellites and modern instruments, large areas remain poorly resolved. Some regions rely on outdated data. Others remain blank in public records. After the Second World War, this uncertainty briefly intersected with human ambition during Operation Highjump. It was the largest military expedition ever sent to Antarctica. Despite its scale, the mission ended early. It left behind incomplete records and unresolved questions. Beneath the ice, scientific discoveries continue to challenge expectations. The Gamburtsev Mountains lie completely buried, yet they appear far less eroded than geological models predict. Hundreds of subglacial lakes have been identified. Among them is Lake Vostok, sealed beneath kilometers of ice for immense spans of time. Its isolation raises questions about extreme environments and the possibility of life without light. Antarctica is also far from inert. Mount Erebus remains an active volcano. It holds a persistent lava lake in the middle of the ice. At the Taylor Glacier, Blood Falls reveals microbial life surviving in darkness. It exists through chemical processes alone. These findings show that heat and life persist where they were once thought impossible. The surface environment adds another layer of uncertainty. Blizzards and whiteout conditions can erase tracks within hours. Over time, explorers and researchers have disappeared during routine activity. They leave behind records that cannot be fully reconstructed. Beneath all of this lies evidence of a radically different past. Fossils and sediments show that Antarctica was once warm and green. It was covered by forests and flowing rivers around 50 million years ago. This was before one of the most extreme climate shifts in Earth's history reshaped the continent. Today, Antarctica is governed by the Antarctic Treaty. It is reserved for peaceful scientific research. This protects the continent. It also limits access. Much of Antarctica remains beyond direct human reach. Tonight, we explore Antarctica through its unanswered questions: hidden mountains and buried lakes, fire beneath ice, life without sunlight, vanished explorers, and a continent that once looked nothing like it does today. If you are interested in exploring the mysteries of Antarctica, remember to like, subscribe, and share this story with others. In the immediate aftermath of the Second World War, the global balance of power entered a rare and unstable phase. Military technology had advanced at unprecedented speed. Fleets, aircraft, and logistical systems built for total war remained fully operational. Nations possessed both the capability and the experience to project large-scale operations into the most remote regions of the planet. It was within this narrow historical window that the United States launched an Antarctic mission unlike any before it. The operation was officially known as Operation Highjump. Planned in late 1946 and executed during the Antarctic summer of 1946 to 1947, Operation Highjump was presented to the public as a combined training and research expedition. Its stated objectives included testing equipment in extreme cold, training personnel under polar conditions, expanding geographic and scientific knowledge of Antarctica. On the surface, these goals appeared routine. The size and structure of the operation, however, suggested something far more substantial. The task force assembled for Highjump was immense by any standard. More than 4,000 personnel took part. 13 ships were deployed. These included an aircraft carrier, destroyers, icebreakers, submarines, and multiple supply vessels. Aircraft were transported south and launched for extensive aerial reconnaissance over vast areas of the Antarctic continent. The logistical planning reflected an operation designed to function independently for many months in one of the harshest environments on Earth. At the time, most Antarctic expeditions were modest in scale and civilian-led. They focused on narrow scientific objectives and limited geographic areas. Even military-supported missions rarely approached the magnitude of Highjump. This was not simply an expedition, it was a coordinated naval and air deployment. It was equipped with capabilities far beyond those typically required for mapping or cold weather training alone. According to initial planning schedules, Operation Highjump was expected to last between 6 and 8 months. Instead, the mission unfolded very differently. Within approximately 8 weeks, operations were sharply curtailed. Aircraft flights were reduced and then halted. Ships were recalled. Personnel began returning north. By early 1947, the expedition had effectively ended. What made this withdrawal remarkable was not only its speed, it was also the absence of a detailed public explanation. There was no announcement of a catastrophic failure or a decisive event that clearly justified such a rapid retreat. While accidents did occur, including aircraft crashes and fatalities, these incidents were not unprecedented in polar exploration. On their own, they did not explain the abrupt conclusion of an operation so carefully prepared. Official statements attributed the early end of the mission to environmental challenges. Harsh weather, ice conditions, and the inherent dangers of Antarctic operations were cited as contributing factors. These explanations were technically accurate. Antarctica is unforgiving, and even well-equipped expeditions face serious risks. Still, for many observers, the reasons felt incomplete. The mission had been planned with full awareness of Antarctic conditions. Extensive resources had been allocated precisely to address them. As a result, Operation Highjump left behind a historical record marked by gaps. Comprehensive after-action reports were not released in full to the public. Much of the documentation remained internal, summarized, or unavailable for independent review. Over time, this absence of detail allowed questions to persist. These questions concerned both the mission's true objectives and the circumstances surrounding its early termination. At the center of later discussion stood Rear Admiral Richard E. Byrd. He was one of the most experienced polar explorers of his generation. He was placed in overall command of the operation. Byrd had spent decades operating in extreme polar environments. He was widely regarded as an authority on both the Arctic and Antarctica. His public statements following the expedition therefore carried significant weight. After returning from Antarctica, Byrd spoke carefully to the press. He did not describe unusual discoveries beneath the ice or unexpected encounters during the mission. Instead, he emphasized the growing strategic importance of the polar regions. He warned that future aircraft could travel from one pole to the other at extraordinary speed. In such a world, distance and oceans would no longer serve as natural defenses. The statement was brief. It was deliberately general. It was never fully explained. That restraint immediately drew attention. Byrd was known for being articulate and descriptive during earlier expeditions. He often provided vivid accounts of terrain and conditions. After Operation Highjump, however, he avoided elaboration. He did not clarify what prompted his warning. He did not publicly address why the mission had ended so abruptly. Combined with the limited release of detailed records, this silence became a focal point of speculation. In the months that followed, newspaper coverage reflected this ambiguity. Reports in the United States emphasized the technical achievements of the expedition. They offered few specifics. In South American press, particularly in Chile and Argentina, Byrd's remarks were quoted repeatedly. They were sometimes reduced to striking phrases about flight from pole to pole. Over time, the strategic context of his warning faded. The mystery surrounding the expedition remained. Outside official accounts, stories began to circulate. Some suggested that Byrd knew more about Antarctica than he was permitted to disclose. others claimed the expedition encountered unexpected conditions. Terrain that did not match existing maps, regions that challenged conventional understanding of the continent. In more speculative retellings, these ideas expanded into rumors of hidden structures, underground systems, even traces of a lost civilization sealed beneath the ice. None of these claims have been supported by verified documents or scientific evidence. Within the scientific community, there is no credible proof of ancient human civilizations in Antarctica. Geological data indicates the continent has been inhospitable for millions of years, yet the rumors persist. They are driven not by evidence, but by uncertainty. Operation Highjump combined three elements rarely seen together: an unprecedented military scale, a sudden and early withdrawal, and a senior commander whose public words were cautious to the point of ambiguity. In a place as inaccessible as Antarctica, where independent verification is rare and direct observation limited, that combination proved enough to ensure the story would never fully settle. Operation Highjump did not result in permanent military bases or territorial claims. It did not reshape Antarctic governance overnight. Instead, it slipped quietly into history. Antarctica itself would later become governed by international agreements. These agreements emphasized demilitarization and scientific cooperation. Yet the expedition continues to be revisited, not because it offers clear answers, but because it left so many questions unresolved. More than 7 decades later, Operation Highjump remains one of the most unusual chapters in the history of Antarctic exploration. It stands as a moment when the frozen continent briefly moved to the center of global attention. Then it retreated once again into silence. It left behind a record defined not by what was revealed, but by what was never fully explained. When ice-penetrating radar began to be used extensively in Antarctica, scientists expected to confirm what geology had long assumed. Beneath the ice would lie an ancient and heavily eroded landscape, one shaped by hundreds of millions of years of slow geological processes. What they found instead came as a surprise. Deep beneath the center of the Antarctic continent, completely buried under kilometers of ice, lay a massive mountain range with sharp peaks and well-defined ridges. It would later be known as the Gamburtsev Mountains. The scale of the discovery was immediately striking. The Gamburtsev range rivals major mountain systems in Europe in both height and extent. Its peaks rise steeply from the surrounding bedrock. Its slopes show clear structural definition. They do not resemble the smoothed and worn forms expected of very old terrain. In radar images, the mountains appear crisp and angular. They seem as if they belong to a much younger geological era. According to conventional geological understanding, this should not be the case. Mountain ranges are typically formed through tectonic collisions. Over time, they are gradually worn down by erosion. Wind, water, and ice reduce even the tallest ranges to low relief over hundreds of millions of years. Antarctica's interior is believed to be geologically ancient and relatively stable. This makes the presence of a well-preserved mountain system deeply puzzling. One explanation suggests that the Antarctic ice sheet itself may have played an unintended role in preserving the Gamburtsev Mountains. Once the continent became fully glaciated, thick ice could have shielded the mountains from further erosion. In this view, the range may be far older than it appears. Its youthful shape may have been preserved by burial rather than recent formation. Other scientists have proposed that deeper tectonic forces may still be at work beneath Antarctica. According to this hypothesis, stresses within the Earth's crust or mantle could be maintaining the structure of the range. They could even be causing subtle uplift. This idea challenges long-standing assumptions about Antarctica as a largely inactive tectonic region. It raises questions about how much geological activity remains hidden beneath the ice. A third line of thought suggests that the Gamburtsev Mountains may be remnants of an ancient continental structure, one formed during the assembly or breakup of a supercontinent long before Antarctica became isolated and frozen. In this scenario, the range would represent a geological relic. It may have been buried rapidly, as climate conditions shifted and ice sheets expanded. While this explanation fits some aspects of continental evolution, it still struggles to account for the range's remarkable preservation. Despite decades of study, no single hypothesis has fully resolved the mystery. Direct access to the Gamburtsev Mountains remains impossible with current technology. Most conclusions are drawn from indirect data. As a result, the range stands as one of the most enigmatic geological features on the planet. Not because it defies science, but because it lies beyond direct observation. The surprises beneath Antarctica do not end with mountains. Radar surveys have also revealed something equally unexpected: the widespread presence of liquid water beneath the ice. Far from being a frozen solid mass, the Antarctic ice sheet conceals hundreds of subglacial lakes. Many of them are connected by hidden water systems. The most famous of these is Lake Vostok. It is a vast body of water buried beneath nearly 4 kilometers of ice. The lake is comparable in size to some of the world's largest freshwater bodies. It has likely been sealed off from the surface for hundreds of thousands, and possibly millions, of years. Its existence alone challenged assumptions about temperature, pressure, and stability beneath the ice sheet. Lake Vostok remains liquid due to a combination of pressure from the overlying ice and heat rising from the Earth's interior. This balance creates a stable environment, one that is isolated from surface conditions and shielded from seasonal change. For scientists, the lake represents a natural laboratory unlike any other on Earth. Efforts to study Lake Vostok have been controversial. The primary concern has never been whether drilling is technically possible. The concern is whether it can be done without contaminating the lake. Introducing modern microbes or chemicals into such an ancient and isolated system could permanently alter it. It could destroy the very conditions scientists hope to understand. As a result, research has proceeded cautiously and often slowly. One of the most compelling questions surrounding subglacial lakes is whether life can exist within them. Some researchers believe that microbial organisms could survive in these dark and pressurized environments. They may evolve independently of surface ecosystems. If confirmed, such life would expand understanding of how organisms adapt to extreme conditions. It could also offer insights relevant to the search for life beyond Earth. Beyond biological questions, subglacial lakes may preserve records of Antarctica's past. Some scientists propose that these lakes were once part of surface water systems, shallow seas, or river networks. These may have existed during periods when Antarctica's climate was far warmer than today. As the continent cooled and ice sheets expanded, these water bodies may have been trapped and sealed beneath the ice. Taken together, the Gamburtsev Mountains and Antarctica's subglacial lakes reveal a continent far more complex than its frozen surface suggests. Beneath the ice lies a dynamic geological and hydrological system, one shaped by forces that remain only partially understood, mountains that appear too young to exist, lakes that remain liquid in perpetual darkness. These features challenge simple models of Antarctica as a static and frozen land. What makes these discoveries particularly compelling is not that they imply extraordinary conclusions. It is that they expose the limits of current knowledge. Antarctica continues to resist easy explanation, not because it hides secrets deliberately, but because its most important features remain physically out of reach. Until technology allows direct access to these buried landscapes, the questions raised by the Gamburtsev Mountains and the lakes beneath the ice will remain open, waiting beneath the continent's frozen surface. Antarctica is one of the few places on Earth where a person can disappear completely. This can happen without violence, without crime, and without human interference. There are no cities, no forests, and no crowds to hide within. Yet history shows that under certain conditions, a human being can vanish only a short distance from safety. They can leave behind no reliable evidence of what occurred. This is not because events are concealed. It is because the Antarctic environment can erase physical traces with extraordinary efficiency. Unlike most regions of the world, Antarctica does not preserve evidence in a stable way. Strong katabatic winds, often exceeding 100 kilometers per hour, constantly move fine snow across the surface. These winds do more than cover tracks. They reshape the ground itself. Irregularities are smoothed away. Shallow depressions are filled. Previous paths and landmarks disappear. After a severe blizzard, the surface of the ice may appear uniform and undisturbed. This can happen even if people or equipment were present only hours earlier. For this reason, disappearances in Antarctica follow a different pattern than those elsewhere. In many cases, individuals do not vanish during dramatic expeditions into unknown territory. They disappear during routine daily activities near research stations. Scientists and technicians regularly step outside to inspect instruments. They move between buildings. They check equipment in nearby areas. When weather conditions change suddenly, these ordinary tasks can become dangerous within minutes. One of the best documented examples is the disappearance of Carl Robert Disch. He was an American physicist stationed at Byrd Station in West Antarctica in 1965. Byrd Station was among the most isolated facilities on the continent. It was located deep within the interior and exposed to rapidly changing weather. According to available records, Disch left the station during poor conditions. He was likely performing a short and familiar task. When he failed to return, his colleagues organized a search. Early reports suggested that some indications of movement were visible in the snow. These observations were limited and unclear. Shortly afterward, a blizzard swept through the area. When the storm ended, no recognizable traces remained. Neither Disch nor any of his equipment was ever recovered. The official conclusion attributed his disappearance to environmental conditions. It noted that the available evidence was insufficient to determine what had happened during his final moments. This case is often described as mysterious, not because of unusual circumstances, but because the environment prevented further understanding. In Antarctica, the absence of evidence does not point to secrecy. It reflects the reality that storms can remove nearly all physical signs of human presence in a very short time. A major contributing factor in such incidents is a weather condition known as whiteout. During whiteout, the boundary between sky and ground disappears. What remains is a continuous field of white with no visual reference points. Shadows vanish. Distance becomes impossible to judge. The horizon cannot be identified. Even experienced personnel can lose orientation quickly. They may walk in unintended directions without realizing it. Cold temperatures intensify the danger. Extreme cold reduces mental clarity. It slows reaction time. It increases fatigue. In these conditions, judgment can decline rapidly. It becomes difficult to recognize when it is time to turn back. What might otherwise be a minor delay can become critical. This is especially true when poor visibility combines with strong winds. Antarctic blizzards differ from snowstorms in inhabited regions. Snow does not simply fall from above. It is lifted from the ground and blown sideways at high speed. This constant movement means that footprints, equipment, and even shallow depressions in the snow can disappear within hours. Over longer periods, the slow movement of ice can bury objects beneath compacted layers. Once buried, they may remain permanently beyond reach. Similar processes have affected vehicles and aircraft. Several aircraft that crashed in Antarctica during the 20th century were not discovered until decades later. Shifting ice or localized melting eventually exposed portions of the wreckage. These cases show that disappearance does not necessarily mean destruction. Often, it means concealment by natural forces that operate continuously over time. Search and rescue efforts in Antarctica are limited by safety considerations. Severe weather can prevent aircraft from flying. Ground searches can become dangerous. Rescue teams must often suspend operations to avoid becoming victims themselves. Once storms pass and surface conditions change, the chances of locating a missing individual decrease sharply. This can happen even when the search begins quickly. Administrative factors also affect how such incidents are recorded. Antarctica is governed by international agreement. It does not belong to any single nation. Each research station operates under its own national program. Incident reports are typically handled internally. As a result, Many disappearances are documented in official records. They receive little public attention. This contributes to their relative obscurity. Over time, the lack of detailed information has allowed some accounts to become exaggerated. Stories of vanishing footprints or unexplained absences circulate widely. They are often detached from their original context. In most cases, however, the underlying explanation is straightforward. The Antarctic environment can remove physical evidence so completely that reconstruction becomes impossible. These disappearances highlight the limits of human presence in extreme environments. Despite modern technology, satellite navigation, and strict safety protocols, Antarctica remains a place where control is temporary. Conditions can change faster than people can respond. Equipment can fail. Communication can be lost. Visibility can vanish without warning. In the end, the unresolved nature of these cases reflects the character of the continent itself. Antarctica does not record human activity in the way other landscapes do. Wind reshapes the surface. Snow redistributes constantly. Ice moves steadily over time. What is left behind is not a dramatic mystery. It is a quiet reminder of how easily human traces can be removed in the most extreme environment on Earth. For early explorers, Antarctica was expected to be a continent of silence and stillness, a place where nothing moved except wind and ice. The discovery of Mount Erebus challenged that belief almost immediately. Rising from Ross Island, Erebus did not dominate the landscape through violence or scale. It dominated through contradiction. In a land of permanent cold, it revealed heat. In a land of silence, it produced sound. As expeditions drew closer, the first detail that unsettled them was the light. From the summit crater, a steady orange glow could be seen. At times, it was visible even through blowing snow and poor visibility. At night, the glow appeared constant. It did not flare like an eruption. It rested in place, as if the mountain itself were quietly illuminated from within. The sight was difficult to reconcile with the surrounding ice and darkness. More troubling than the light were the sounds. Journals from early expeditions describe deep, low-frequency noises coming from the mountain. These were not sharp explosions or sudden cracks. They were slow, resonant pulses that traveled across the ice. Some described them as distant thunder. Others compared them to heavy machinery. That comparison felt unsettling in a place untouched by industry. At times, the sounds arrived in regular intervals. They were followed by long periods of silence. Without modern instruments, explorers could not measure what they were hearing. They could only describe the effect. The mountain seemed active, but not violent. It did not erupt. It exhaled. The sound suggested movement below the surface, something shifting and circulating far beneath the ice. Rumors spread quietly among crews. Erebus was said to contain vast chambers of heat, or systems far larger than any known volcano. At the center of the mountain lay its most unusual feature. Erebus contained a permanent lava lake. It was exposed directly to the open air. Molten rock remained liquid despite surrounding temperatures that could fall far below freezing. Gas bubbles rose through the lava and burst at the surface. They released sound and vibration into the surrounding rock. The volcano appeared stable, yet never dormant. In later years, volcanology would explain much of this behavior. Erebus is one of the few volcanoes on Earth with a long-lived lava lake. The sounds are produced by magma movement and the release of volcanic gases. Yet even with these explanations, Erebus remains unusual. Its internal structure is complex. Its behavior resists simple modeling. Erebus stands as evidence that Antarctica is not inert beneath the ice. Heat, pressure, and movement continue below the frozen surface. They are unseen but persistent. For the explorers who first encountered it, the mountain altered their understanding of the continent. Antarctica was not only cold and empty, it was active. Far from volcanic heat, another Antarctic mystery revealed itself in near silence. At the edge of the Taylor Glacier, in the McMurdo Dry Valleys, explorers noticed a dark red liquid slowly emerging from the ice. It flowed steadily, staining the glacier with rust-colored streaks. Against the white and blue of the surrounding ice, the color was unmistakable. The phenomenon became known as blood falls. The flow did not behave like surface meltwater. It appeared even in extreme cold. Its source lay within the glacier itself, not above it. For decades, no clear explanation existed. Early observers proposed algae, mineral runoff, or surface contamination. None fully accounted for the persistence or depth of the color. Unlike Erebus, blood falls made no sound and emitted no heat. It simply appeared, slowly and consistently, as if the glacier itself were bleeding. The phenomenon remained unresolved for many years. It was noted in passing but rarely understood. When scientists eventually analyzed the water, the explanation proved more remarkable than expected. The red color came from iron-rich brine. When the liquid reached the surface and contacted oxygen, the iron oxidized. This produced the deep red hue. But within the brine, researchers found something far more significant. The water contained living microorganisms. Beneath the Taylor Glacier existed a sealed environment. It was isolated from sunlight and the atmosphere for hundreds of thousands, possibly millions, of years. The microorganisms living there did not rely on photosynthesis. Instead, they survived through chemical reactions involving iron and sulfur. They extracted energy directly from their surroundings. In complete darkness, under high pressure and extreme salinity, life persisted. The glacier acted not as a barrier, but as a protective cover. It preserved an ancient ecosystem beneath its weight. It shielded that system from surface changes while allowing biological processes to continue. Blood falls was not merely a chemical anomaly, it was evidence of life adapting to conditions once thought impossible. For early explorers, the sight of red water flowing from ice would have been deeply unsettling. For modern science, it became transformative. It demonstrated that life does not require light, warmth, or open air in the way once assumed. It can persist quietly, hidden beneath ice, sustained by chemistry rather than sunlight. Together, Mount Erebus and blood falls reveal a different Antarctica. Fire exists where cold dominates. Life survives where darkness prevails. These phenomena do not suggest myth or mystery in a supernatural sense. They reveal a continent that continues to function beneath its frozen surface. Antarctica appears still from a distance, but beneath the ice, the Earth remains active. Life finds ways to endure. Erebus glows in the cold. Blood falls flows from ancient ice. These are not contradictions. They are reminders that even the most extreme environments on Earth are rarely as simple as they appear. Today, Antarctica is known as the coldest, driest, and most isolated continent on the planet. It is covered by a vast ice sheet, several kilometers thick. Its interior is one of the most hostile environments humans have ever encountered. However, this image represents only the most recent chapter in a much longer history. Scientific evidence now shows that Antarctica was once a green and relatively warm land. It supported forests, diverse plant life, and a climate entirely unlike the frozen world we see today. Fossilized plants and sediment cores collected from Antarctica reveal that around 50 million years ago, during a period known as the Eocene epoch, the continent supported dense forests. These forests included species related to modern beech trees, ferns, and even palm-like plants. Such vegetation could not survive in freezing conditions. This means Antarctica's climate at the time was warm enough to sustain long growing seasons and liquid water at the surface. Chemical analysis of sediments further supports this picture. The composition of ancient soils and marine deposits indicates temperatures far above freezing. Some regions likely experienced summer conditions comparable to those of modern temperate zones. Antarctica was not a marginal environment struggling to sustain life. It was a functioning ecosystem. It was connected to global climate systems and influenced by ocean currents and atmospheric circulation. The transformation from this green continent into the frozen landmass of today represents one of the most dramatic climate shifts in Earth's history. Over millions of years, A combination of tectonic movement, changes in ocean circulation, and declining atmospheric carbon dioxide levels gradually cooled the planet. As Antarctica drifted farther south and became isolated by the formation of the Southern Ocean, warm currents that once reached its shores were diverted away. This isolation allowed cold water to circulate around the continent. Ice formation accelerated. Despite decades of research, scientists still debate the precise timing and pace of this transformation. Some evidence suggests that cooling occurred in stages. Periods of relative warmth were followed by rapid ice expansion. Other data point to threshold events. Small changes in greenhouse gas concentrations may have triggered large-scale glaciation. What is clear is that once large ice sheets formed, they reinforced cooling. Sunlight was reflected back into space. Antarctica became locked into its frozen state. This ancient climate history is not merely a curiosity. It makes Antarctica one of the most important locations on Earth for understanding how sensitive the global climate system can be. The continent preserves a long record of environmental change. This record is written into ice cores, sediments, and fossil remains. By studying how Antarctica responded to natural climate shifts in the past, scientists hope to better understand how modern climate change might unfold. Antarctica's green past serves as a reminder that even the most extreme environments on Earth are not fixed. Over geological time, they can transform completely, given the right conditions. That lesson has become increasingly relevant as researchers examine the stability of today's ice sheets. They also consider the potential impact of those ice sheets on future sea levels. Antarctica does not lend itself to clear conclusions. It is a continent defined by what cannot yet be reached. Beneath its vast ice sheet lie records of climates, landscapes, and processes that shaped the Earth long before humans existed. Yet most of this history remains sealed beneath kilometers of ice. What we know comes largely from indirect signals, from radar, from seismic waves, from fragments recovered at the edges of the continent, not from direct observation. Viewed as a whole, these events and discoveries reveal a consistent pattern. Operation Highjump shows how even the largest human efforts can withdraw without fully understanding the environment they enter. The buried Gamburtsev Mountains and the lakes beneath the ice reveal a landscape far more complex than the flat surface suggests. Mount Erebus and Blood Falls demonstrate that heat and life persist where they seem least possible. Even human disappearances reflect the same reality. Antarctica does not conceal evidence deliberately. It can erase it completely. The true mystery of Antarctica is not a single hidden discovery. It is the scale of what remains inaccessible. It is a place where major questions about climate, geology, and life are still open. Not because answers do not exist, but because the continent itself limits our ability to reach them. If you enjoy exploring mysteries like these, remember to like the video, subscribe, and share your thoughts in the comments.